guys, so this is like that. Okay, so let's do some questions, guys. Right, we were doing questions on DP and DP discussion we are done. We are doing this. We are doing this, right? Longest increasing subsequence. Okay. So you have given an integer array nums. Return the length of the longest strictly increasing subsequence. Okay. So it's a medium type question. Let's see what happens here. Okay. So this is the question. Right. Okay. Now you have given an integer array nums. Return the length. Okay. All right. Okay, so we have this integer array nums, right? What we have to do now? Is return the length of the longest strictly increasing subsequence, right? Let's say this we have to return longest strictly increasing, right? So subsequence. So what it can be? Let's say this is array we have 10, 9, 2, 5, 3, 7, 1, 0, 1 and 18, right? Now we have this. We can have like 9, 101, like this two length, right? We can have 9 and 18. This is we can have 2. We can have 3, 7, 101 or 18, like this. Okay. So strictly increasing should be there, and so how can we do that? Let's say we are starting from here, right? We are starting from here, and if it is greater than, if 9 is greater than this, no, we go further. This no, this no, right? So we reached here. So it will give plus. In this case, we can take it or we don't take it, like that, right? Okay, and we have choices there, right? Okay. So let's say, or we can do like we can start from here, we can start also from here. So that's the case. Okay. So let's try to code that, because let's say we are here, we can start from 10 or we can start from 9, or we can start from 9 or we can start from 2. But let's say if we are starting from 2 here, right? So it is 5. This 2 can take 5 or don't take 5. It goes 3. Whichever gives this longest increasing sequence, then it will return the answer, right? Okay. Let's try to code this. We have this function, right? It will have this vector of integer nums, then index it is okay. And if I is greater than or equal to nums dot size, then this will return 0, right? But if nums of I is greater than nums of I plus 1 greater than nums of I, right? Then we have two choices, like int take is equal to 1 plus f of nums comma I plus 1, right? And we can skip the take also, right? F of nums comma I plus 1, right? Else if and we will return max of take comma skip is, right? Also if it is not like this, if it is not big, right? If it is not big, like it's small 2, then what we can do, we in this case else we can take that and we can not take that also, right? Or we can just return this return f of nums comma I plus 1, right? Like that. So let's dry run this code. Let's dry run this code here. First change this color, bro. Very terrible. Okay, let's let it go. Let's dry run on this. Right. Alright. So let's say we are finding longest increasing in this 9, 2, 5, 3, 18, right? Okay. So we are starting from 9. Then goes here. If nums of I plus 1 is greater than no, it will go this here. Return nums of I. Okay. So it will go for 2. Alright. Then so it's not considering this. So we have this. I think we should have this else case also. If it is not that case, then we go for like skip, right, comma start. So so it's a 1 plus f of I, like that. Or is it like should I continue finding if I can find this greater element for this, right? Okay. Okay, so f of I went to 2, let's say. I plus 1 is greater, okay, 1 plus this 5, right? It will go in else part. I plus 1. No. So I should have one element also current, right? Current where I am, right? And I, which is index. So if it is current greater than current, then we will have choice. Else current I plus current is like that, right? Okay, so like this. I will have this index also, right? One should be current, and the current, right? Like this. Of current, therefore I is greater than current. Okay, current like this. Current will be same. Okay, alright. If num I is greater than that, else return this. If it is greater, alright. Okay, so I can return like this, alright. Else case can be built here. Wait. We have to return max of this comma f of nums comma I plus 1 comma current plus 1. Right. Okay. So we are returning f of nums comma 0, right? Or current equal to nums dot size, right? In that case also we will return 0. We will go to say return to 0. Let's try this. Okay, 1 plus current, and if we are splitting this current, okay. What happened? Okay, we are on request to has passed. Let me see guys what happened here. My output is 5, expected is 4 here, case 2 is passing, case 3 0 1. Okay. So this is little bit of confusion here, I think. Okay, I can start with 1 here, right? Current is 0 and this is 1. I think it's only similar, there is no much difference here, okay. Yeah. No much difference. Current. We are skipping that, okay. Okay, let me see. Return skip take. Skip. We are skipping the take, right? And what is the? Okay, so okay, the current will be current plus 1 here, right? Because we are skipping the right. I think that should increase some chances of. Now case 1 is running. Wow. So now case 1 is running, guys. Now case 2 is not running. Neither case 3 is running. Okay. Okay. And we are taking that, right? Or we can say current is I. If nums I is greater than nums dot current, we are taking that current is I, right? And skip take current will be current I is 1, right? And okay. And here we don't have that, so skipping, right? I can, okay. Yeah, I plus 1 and current plus 1, I think this way, right? But if I am just skipping, because it is not, so I plus 1 is the current will be same, okay, comma, we are increasing both current I and current I. Let's see. Now all the questions are long. Okay, let me ask the master. Do you know the master? This is the master, guys. So you have arrived at one of the absolute pillars of algorithm theory, the longest increasing subsequence. Your intuition to track the both current index and the previous chosen index is exactly right. Mathematical framework for this problem. Okay, however, the code has fallen to 100-foot anchor trap. Okay, and teleporting builder trap. Okay. Here is the real world ethical breakdown of this code breaks and how we fix it. Right. The bug of one is 100-foot anchor trap is wrong initialization. Look at your starting function. Return nums like this. Real world analogy, you are a builder trying to build the tallest possible staircase by passing current is equal to 0. You mathematically build that very first step of your staircase to where whatever block is sitting at nums 0. Okay. What if the area is 100, 1, okay, you lock your previous step at 100, okay. So when you look at this, you say smaller than 100, you can't use them. Okay, return length 1. Mathematically, you must represent a state where 0 blocks have been placed yet. Okay, so we do it mathematically by starting at previous index at -1. Okay. The teleporting builder corrupted timeline, like look at else block when current number is too small to be kept, else return like this. You look at a block and it's too small and decide to skip it. You correctly evaluate nums I plus 1 current, move into the next block while keeping the anchor the same. But when you evaluate nums I plus 1, what does this mean? You might already told your brain, I am not taking this block, but I am going to magically pretend my anchor point to shift it forward away. Mathematics, if you do not take nums I, your current index must remain identical. Shifting to current plus 1. Corrupt the timeline and reference element and never actually include the subsequence. Okay, so 2D coordinate shift trick. Because we are introducing a -1 into current parameter, we hit a new problem. C plus 1 arrays cannot have a -1 index. And crash, to fix this manually, we simply shift the entire current. Okay, so don't give me this. First give me a recursive solution, bro. Right? Okay, real and imagine you are trying to win a large possible installation. Okay, so force escape. If the current block is shorter than the equal to your anchor, you physically cannot place it. You must skip it and move to the next block. Timeline shift. If the current block is shorter than your anchor, you have two choices. Take it, block, okay, becomes a previous anchor. This block becomes a previous anchor, and skip it, you ignore the particular block because you can reference that is not okay. We'll ask about timelines to play that next. Okay, I count previous, I plus 1 count previous, okay. Always possible to skip, okay, 1 plus LS, I plus 1, comma I, okay. If previous is equal to skip -1, or nums I greater than nums previous. Okay, so let's see what's nums of the length is equal to the current element. Okay, if we are skipping the current element, previous I. So previous anchor is prep, and if we are skipping the current element, okay. I want to take the current element if it is valid. If previous is not equal to -1 or nums of I is greater than nums of previous anchor. Right, what we have to do? We have to take the max of length. Okay. 1 plus f nums I plus 1 comma I. Alright. And return the length. 0 comma -1. Okay. So let's try this. Right. Let's try this solution also here. So let's say 0 comma -1. Current is our anchor point, okay. So let's go here. If nums I is greater than nums of current, we will do this. Okay. Let's see what happens. Yeah. Or current equal to -1. Right, we are taking f of nums 1 plus I return is I here, okay, and we can skip it also, right? here is current increasing in this case. Here it's increasing when we are taking it. Right, this is increasing. But if it is not small, right? Okay, so what I can do guys is, let's play the game. Right, let's take this return element and go here. Okay, okay. Okay, so and the LAN is this what's happening here guys, because we are just taking another again and again element, right? F live I plus 1, we are just increasing I, and when this I goes okay, so let's try on this guys, we will understand it better. Right, let's drag on this. Right, 925,380. Right. We have this 925,380. So we are at here I is here. Right. Okay, so len is f of nums I plus 1 current. So I will go to 2, 5, 3, 18. Current is minus 1 and 1. Okay. Then it goes to 5, 3, 18. Then it goes to 3, 18. It is to 18. Then it will return 0 here. Right. After that I is here, right? If current is 18, current is equal to nums f of nums. Okay, so current is minus 1, right? Yeah. So nums I is greater than current. Yes, 18 is there. So 1 plus to nums of I plus 1. Then current will be this at 18. Nums 1 plus, there will 0, it will return 1 only. Right? There will be return 1, makes of len is ordered 1, comma t. Okay, so it was 2, 2, it will return 2 from here. Then it will move here. So we have 2 here, right? Then it will return to this part. I is here, right? is 5 is greater than 9? No. No, right? Okay, so it will return 2 only. Return len, right? Len is equal to 2. Okay, then is will be 2, it will return 2, and 9 will return 2 only. Okay, after that, after returning 2, where it goes? It goes to num. It will find this also, right? 2, 5, like this. It calls these functions also. Right, right. So let's watch the video of Striver to understand this better. Otherwise, we can uh,
Hey everyone, welcome back to Take You Forward. Today we will be starting with another pattern of DP, which is the LIS pattern, or the longest increasing subsequence pattern. Now we have done some problems on subsequence. If you remember well enough, the DP 13 to DP 22 was based on DP on subsequences, but this is slightly different than that. Okay, now longest common subsequence. All of you know what is the definition of subsequence. Like if I give you an array of n numbers, any contiguous or non-contiguous, like you can pick up 10, you can pick up 2, then you can pick up 5, then you can pick up 7, then you can pick up 101. So if I write this, this is a subsequence. Okay, but if you write something like this is not a subsequence. Why? 5 and 2 have swapped places, thereby it's not a subsequence. Any contiguous, like it can be 9, 2, 5, this is a subsequence. As long as you're picking elements that follow the order, like if 9, after that 2, after that 5, if it's following the order, then you call it as subsequence. Now as the name suggests subsequence, it's clear to you. As the question name is suggesting, figure me out the longest increasing subsequence. So among this, if I try to figure out different types of subsequences, I can say one of them is 10, 101. This is a subsequence of length 2. And if I say I can figure 9, 101, that's again another subsequence of length 2. I can similarly say 5, 7, 101, 5, 7, 101. The length is 2. Similarly, I can say that, hey listen, let's pick up 2, let's pick up 3, let's pick up 7, let's pick up 101. If I pick up something like this, I will be getting a length of 4. Even if I pick up something like 2, 3, 7, 18, this also gives me a length 4. So the question over here is very straightforward. You need to tell me the longest increasing subsequence, the length of it. Yes, over here we will be solving length. Going forward in the next set of videos, I'll also be telling you how to print this particular subsequence. Okay, so that's the question. You have to tell me the length of the longest common subsequence. So just a quick recap, if you remember well enough, in all the subsequence problems, we followed a simple pattern.
हेलो, गुड आफ्टरनून मैम। मैम बहुत थोड़ी प्रॉब्लम हो गई है। क्या है कि कई, अरे आपकी आवाज़ में बहुत हो रहा है। हाँ हेलो, सुनो एक, या सो वो है कि मैंने ऑर्डर किया था 13th को, तो अभी तक कोई अपडेट ही नहीं है मैम, वहाँ से शिप ही नहीं हुआ। ये क्या हो रहा है मैम यार, मतलब मैम ऑर्डर आईडी में 50 बार ऑर्डर आईडी बता चुका हूँ आपको। 2723 8। हेलो, हाँ मैम 2723 8। क्या मैम, वो क्या है, सुनो, वो पहले भी डिस्कस हुआ था कि टी शर्ट अवेलेबल नहीं है, तो मैंने क्या करा, आपने पूछा कि आप दूसरी से एक्सचेंज कर लो, तो मैंने आपको उसको कार्ट में भी ऐड कर दिया था दूसरी टी शर्ट को, और आपको फ़ोटो भी भेजी है चैट में, व्हाट्सएप पे, ठीक है। तो आपने वो भी एक्सचेंज नहीं करा, 4-5 दिन उस बात को हो गई। हाँ वो ब्लैक वाली भेजी है। हाँ हेलो मैम, हाँ बोलिए। हाँ हाँ, और वो ग्रीन वाली जो ऑर्डर करी है वो भी अवेलेबल नहीं है। अरे तो वहाँ तो स्टॉक में दिखाता है मैम, क्या करते हो आप? तो क्या क्या हाँ ये काम कर दो बस, धन्यवाद। कब तक आ जाएगा मैम ये? बहुत बहुत धन्यवाद आपको, भिजवा दो।
right? That was pick, or you can say take, pick or take, or not take, like take and not take, or pick or not pick. This was the pattern that we followed. Either we took the guy, or either you did not take the guy. So you're gonna remember this pattern, like either you take it, or either you decide that you're not going to take it. This is the stuff that you have to follow. Okay. Now going forward, if I ask you what is the longest common subsequence of this particular array, the answer to that will be, listen, the length is 1. Why? Because it clearly states, understand this particular word, it clearly states increasing. You cannot have equal elements. It has to be increasing. Like you see 2 is, you see the increasing pattern, it has to be increasing. So the question is very straightforward. You have to figure out the length of the longest increasing subsequence. Got it? So the length is 1 over here, which is nothing but a single array of size 8, a single array of size 1 which contains 8. Cool. So how do you solve this particular problem? I know there can be various subsequences which can be answers. So the first thing that comes to my mind is, let's try out various subsequences. Like the brute force technique that comes to my brain is, hey Striver, let's print all the subsequences. Like let's print all subsequences. I'll be like, okay, makes sense. And if you have seen my previous videos, how can you print all the subsequences, guys? Obviously, you can use power set, or you can use the recursion, both of which I have already taught on this channel itself. Either you can use the power set, or either you can use the recursion in order to generate the subsequence. Once you've generated one subsequence, then you can easily see if it is increasing, check for increase. That's the brute force I'm talking. Generate all the subsequence, check for increase, store the longest among them. Store the longest. So that's going to be the brute force. Like I will not be diving deep into it because you can just go across and watch power set or recursion, generate all subsequences. Once the subsequence is generated, you just at the end of the day see if that subsequence is increasing or not, and if it is, then you check for the longest portion. So that's the brute force. And in order to generate all the subsequences, you have to figure out the length. length of the longest increasing subsequence. Got it? So the length is 1 over here, which is 9. longest common subsequence of this particular array? The answer to that will be, listen, the length is 1. Why? Because it clearly states, understand this particular word, it clearly states increasing. You cannot have equal elements. It has to be increasing. Like you see 2 is, you see the increasing pattern, it has to be increasing. So the question is very straightforward. You have to figure out the length of the longest increasing subsequence. Got it? So the length is 1 over here, which is nothing but a single array of size 8. A single array of size 1 which contains 8. Cool. So how do you solve this particular problem? I know there can be various subsequences which can be answers. So the first thing that comes to my mind is, let's try out various subsequences. Like the brute force technique that comes to my brain is, hey Striver, let's print all the subsequences. Like let's print all subsequences. I'll be like, okay, makes sense. And if you have seen my previous videos, how can you print all the subsequences, guys? Obviously, you can use power set or you can use the recursion, both of which I have already taught on this channel itself. Either you can use the power set or either you can use the recursion in order to generate the subsequence. Once you've generated one subsequence, then you can easily see if it is increasing. Check for increase. That's the brute force I'm talking. Generate all the subsequence, check for increase, store the longest among them. Store the longest. So that's going to be the brute force. Like I will not be diving deep into it because you can just go across and watch power set or recursion, generate all subsequences. Once the subsequence is generated, you just at the end of the day see if that subsequence is increasing or not, and if it is, then you check for the longest portion. So that's the brute force. And you know, in order to generate all the subsequences, you end up taking 2 to the power n time, because if you are generating all the subsequence, the number of subsequence for a length n is nothing but 2 to the power n. We know that, right? So that's not something, because this is nothing but exponential in nature, and this will give us a TLE. So the brute force will definitely not work of generating all the subsequence. So the brute force does not work. Then what? We are trying always. We are trying always. And we know we can do via recursion. Perfect, we can do via recursion. And if you're doing via recursion, remember this, if you're doing via recursion, we can probably try to write recurrence. We probably can try to write recurrence. And after that, we can see if it can be memorized or not, that is afterwards. But if you're trying to write the recurrence, what is the rule to write recurrence? The simple static rule to write recurrence is express everything. Yes, I've been telling this from the first lecture in DP playlist. Express everything in terms of index. Explore all possibilities in subsequences. You know, in subsequences, either you pick or either you don't pick. These are the couple. And then you take. Now you need the longest. That means the max length of both. Max length of not take, and take is what you'll take. That's the generic way to write. Explore all possibilities in subsequences. You know, in subsequences, either you pick or either you don't pick. These are the couple. And then you take. Now you need the longest. That means the max length of both. Max length of not take, and take is what you'll take. That's the generic way to write the recurrence. So we know that we have to express everything in terms of index, because over here we're definitely sure we are given an array. So an index will always be there, which we can start from here, which is the 0th index. We definitely know there is going to be an index, right, which can start from 0. Now I need to understand if this portion can be a part of my subsequence or not. Can this be a part of my subsequence if I ask you? You'll be like, yes, because it's the first element. You can go on and say, yes, this can be a part of my subsequence, or cannot be. You say, I'll not take 10. Like either you say, I'll form a subsequence which has a 10, or either you'll say, I'll not have 10 as subsequence. Now imagine, just ask your brain. Imagine you take this 10 to be the part of your longest increasing subsequence. For an example, you take 10 to be the part of your longest increasing subsequence. Now you move to 9, so the index moves to 9. Can 9 be the part of the same subsequence? And the answer to that is no. Why? Because your brain says, hey Striver, we previously took 10. We're looking for increasing. So we cannot have 9 as the part of this particular subsequence. Let's repeat. We previously took 10. We previously took 10. So we cannot take 9 at the current index. Yes, you heard that correct. You have to keep a store of the and start from 0. Now, I need to understand if this portion can be a part of my subsequence or not. Can this be a part of my subsequence if I ask you? You'll be like, yes, because it's the first element. You can go on and say, yes, this can be a part of my subsequence, or cannot be. You say, I'll not take 10. Like either you say, I'll form a subsequence which has a 10, or either you'll say, I'll not have 10 as subsequence. Now imagine, just ask your brain. Imagine you take this 10 to be the part of your longest increasing subsequence. For an example, you take 10 to be the part of your longest increasing subsequence. Now you move to 9, so the index moves to 9. Can 9 be the part of the same subsequence? And the answer to that is no. Why? Because your brain says, hey Striver, we previously took 10. We're looking for increasing. So we cannot have 9 as the part of this particular subsequence. Let's repeat. We previously took 10. We previously took 10. So we cannot take 9 at the current index. Yes, you heard that correct. You have. Now you move to 9. So the index moves to 9. Can 9 be the part of the same subsequence? And the answer to that is no. Why? Because your brain says, hey Striver, we previously took 10. We're looking for increasing. So we cannot have 9 as the part of this particular subsequence. Let's repeat. We previously took 10. We previously took 10. So we cannot take 9 at the current index. Yes, you heard that correct. You have to keep a store of the previous, because if you're deciding whether you take 9 or not, you have to understand what you took previously. So someone has to tell you that you took previously the 0th index, which is 10. Someone has to tell this. So apparently what I can say is, I can express the recurrence in terms of index and previous. Why previous? Because previous allows us to make a choice whether I can include this index in my subsequence or not. I need to know who is the previous. So I need to carry the previous index as well. Like who was the previous index? That was the part of my subsequence, right? So initially when you're starting off, you can say f of 0, -1. Basically saying 0. This is the first guy, and since he's the first guy, there is no previous index as such, so I can mark it as -1. So this means, give me the length of LIS starting from 0 with no previous element. If I write f of 3, 0, this means length of LIS starting from third index whose previous index is 0. Let's understand this. Length of the alias starting from the third index whose previous index is 0, which means 1, 2, 3. If you're here, third index whose previous pick or either you don't pick. These are the couple. And then you take, now you need the longest. That means the max length of both. Max length of not take and take is what you'll take. That's the generic way to write the recurrence. So we know that we have to express everything in terms of index. Because over here, we're definitely sure we are given an array. So index will always be there which we can start from here, which is the 0th index. We definitely know there is going to be an index, right? Which can start from 0. Now, I need to understand if this portion can be a part of my subsequence or not. Can this be a part of my subsequence if I ask you? You'll be like, yes, because it's the first element. You can go on and say, yes, this can be a part of my subsequence. Or cannot be. You say, I'll not take 10. Like either you say, I'll form a subsequence which has a 10, or either you'll say, I'll not have 10 as subsequence. Now imagine, just ask your brain. Imagine you take this 10 to be the part of your longest increasing subsequence. For an example, you take 10 to be the part of your longest increasing subsequence. Now you move to 9. So the index moves to 9. Can 9 be the part of the same subsequence? And the answer to that is no. Why? Because your brain says, hey Striver, we previously took 10. We're looking for increasing. So we cannot have 9 as the part of this particular subsequence. Let's repeat. We previously took 10. We previously took 10. So we cannot take 9 at the current index. Yes, you heard that correct. You have to keep a store of the previous, because if you're deciding whether you take 9 or not, you have to understand what you took previously. So someone has to tell you that you took previously the 0th index, which is 10. Someone has to tell this. So apparently what I can say is, I can express the recurrence in terms of index and previous. Why previous? Because previous allows us to make a choice whether I can include this index in my subsequence or not. I need to know who is the previous. So I need to carry the previous index as well. Like who was the previous index? That was the part of my subsequence, right? So initially when you're starting off, you can say f of 0, -1. Basically saying 0. This is the first guy. And since he's the first guy, there is no previous index as such, so I can mark it as -1. So this means give me the length of LIS starting from 0 with no previous element. If I write f of 3, 0, this means length of LIS starting from third index whose previous index is 0. Let's understand this. Length of the LIS starting from the third index whose previous index is 0, which means 1, 2, 3. If you're here, the previous index is 0. What is the longest length you can get if the previous is n? That is what it means. Make sense? That is the definition of the function. So I can say, instead of index, third I can write index, and instead of this I can write previous index. That is the definition of the function that we will define. Okay. Now since the definition is clear, we have expressed everything in terms of index and previous index. So let's write it super quick. Index and previous index. Very, very simple thought process. Let's write the base cases afterwards. Now, what's the first thing that you write in recursion? Very straightforward. It is either you take that element into yourself, or either you say this is not going to be the part of my subsequence. Because explore all possibilities means, if you are standing at this particular 10, you say 10, come and be my part. Hey, come across and be my part. Or you say 10, don't be my part. So I can say there are a couple of ways, which is you're saying 10, be my part, or you 10, don't be my part. So I can say, instead of index, third I can write index, and instead of this I can write previous index. That is the definition of the function that we will define. Okay. Now since the definition is clear, we have expressed everything in terms of index and previous index. So let's write it super quick. Index and previous index. Very, very simple thought process. Let's write the base cases afterwards. Now, what's the first thing that you write in recursion? Very straightforward. It is either you take that element into yourself, or either you say this is not going to be the part of my subsequence. Because explore all possibilities means, if you are standing at this particular 10, you say 10, come and be my part. Hey, come across and be my part. Or you say 10, don't be my part. So I can say there are a couple of ways, which is you're saying 10, be my part, or you 10, don't be my part. So let's write the non-part at first. If I'm saying someone, you are not my part, which eventually means I am moving to the next index. And if this particular index is not the part of the subsequence, can I say the previous index still stays the same? It does. So thereby, the previous index still stays the same. And if you're not including it into the part of your subsequence, will the length, because this function returns the length, if you remember the definition, it returns the length. So will the length increase? The answer to that is no. Thereby, we will have no increase. And this is for the not take case. Now you have to write for the take case. But the take case has some conditions. Let's understand. This is very simple. If you're not taking, you move to the next index. And since you're not taking, whoever was the previous still stays as the previous. Quite straightforward. Okay. Now let's talk about the next choice. It's the take choice. Okay. Let's come across and see. Can you take this 10? Always less. Why? Because it is an element which does not have a previous index. Okay. So when you decide to take this 10, let's draw the recursion tree and try to visualize. If you are at f of 0 minus 1, you say I'll take 10. Assume it was 10 and 9, something like this. You say I'll take 10. So if you take 10, you are saying the previous index is now the 0th index, and you move to the next, which is the first index. And the length will also increase by 1. That's when you take it. That's when you take it. If you don't take, what happens? You move to the next, which is the first index, and the previous still stays as minus 1. But you move to the 9th guy. Okay? And over here, assume there is something like 18. Now, whenever you are at this, now you can again take 9. Remember this. You can again take 9. So if you take 9, you'll move to the second index. You'll move to the second index, and you'll say, if you're taking 9, the first guy becomes your previous index. The first guy becomes your previous index. So over here, you're saying, don't take the first guy, take the second guy. So you're having a subsequence of 9. So, but over here, if you have taken the 0th guy, can you take the 9th guy? No. Why? Because you're looking to form longest increasing. And if you take this 9, if you take this 9, then eventually you're taking 10 and 9. Thereby, it will be decreasing. So, are you getting a pattern? Yes. If it's minus 1, which states it does not have a previous element. If it's minus 1, which states it does not have a previous element. And if it is, or if the current index exceeds the previous index, if there is some, then I can definitely take it. And if I am taking it, either this is a length, the length will be 1 plus f of, I move to the next index, and the previous index will now be, since I'm taking the current index, that will be the previous index now. And I'll move to the next saying, go and check if this guy can be your previous or not. And this is the new length if you decide you are going to take. So this was the previous one when you decided to not take. So I need the max of both. So can I say it will be length equal to max of either the not take length, which is this, or the take one. At the end of the day, I can simply return the length. And that's how you can easily write the couple of conditions. This is going to be your take condition. This is going to be your not take condition. Couple of conditions easily written. So have I explored all the options? I have. Now, taking the max length, I do. What's the next thing? I forgot the next thing, which is base case. When do you end? That's my question. You know, in subsequences, you end when you run out of elements. So can I say, if I am going, can I say over here, right after this, which is n minus 1, and the next one will be n, can I say I'll run out of elements at the nth index? I will. So if I'm running out of the elements at the nth index, can I write something like, hey, I am running out of index. I don't have any more elements. So if I do not have any more elements, what will be the length? I will give you a length of 0 because I don't have anything. That's the shuttle base case. These are the couple of stuffs, and this is the length that I'm talking about. So in this way, you can easily make it a recursive solution. Okay. Now if you're making a recursive solution, you know one thing for sure, the time complexity is going to be 2 to the power n. Why 2 to the power n? Because for every index, you're having two options. Take or not take. Take or not take. Take or not take. So in total, it will yield 2 to the power n number of operations. So the time complexity becomes this. And the space complexity will be an auxiliary stack space of big O of n. Because you're going across a stack space of till n. This is the stack space that you'll be taking. So there will be an auxiliary stack space of big O of n. And the time complexity will be 2 to the power n. Obviously, this is exponential. And I will be looking to optimize this. And you have been going through the entire DP playlist. You know, how do you optimize a recursion? That's very simple. You say, I see for overlapping subproblems. And if you draw the entire tree, I'm very much sure you will find overlapping subproblems. Try to draw the entire tree. Like this is the symmetry that I've drawn. Try to draw the entire tree and you will see that there are overlapping subproblems. And if there are overlapping subproblems, what you do is you tend to convert that into memoization. And how do you convert it into memoization? You look at the variables that you have passed in function. One is index, one is previous index. Say like, okay, what is index? I see index is nothing but from 0 to n minus 1.
Okay, so we can convert to the recursion and memoization by ourselves. So I think no need to for this. Okay, let's try to submit it. It will give us TLE. Okay, so how many variables are changing? Current is changing and I is changing, right? Okay, so what we have a DP vector DP of n comma vector of n comma minus 1, right? What is n and n is equal to numbers both sides, right? Both sides. We can pass this as here. DP and C. Okay. As a reference. And if DP of I comma current is not equal to minus 1, it DP of I comma current, else it okay, so we can do this and then we create I comma right, and we can pass DP in this here, right, and also we can pass DP here. Let's check what should be in this. If it is okay, so because it's starting with minus 1, so we can increase this in plus 1 size, right? Alright, so we are setting everything. Okay, so it's 8 plus 1 and current plus 1. Okay, 8 plus 1 current plus 1. Everything like this. Alright. Plus 1, plus 1 like that. Alright, we can shift it and right further. And again the camera, right, so okay. This also. Okay. What is the problem here? Let's see.
Thereby, in order to store it in some array, I can definitely use an n size because then I'll be allocated 0th index till n minus 1th index. What's the next thing? Previous index. But there's a problem with previous index. This starts from -1 and goes till n minus 1. So, if you're using a 2D array, how do you store -1? Because you cannot. Because you know, in arrays it starts from 0 based indexing, so you definitely cannot. So, how can you store this? What you do is you say, okay, I cannot store previous index, but can I do a coordinate change? Can I do a coordinate change in memoization? Now I'll be like, what do you mean by coordinate change? I say, okay, fine, I have -1, I have 0, I have 1, I have 2, till I have n minus 1. Now whatever -1 is, whatever -1 state is, instead of storing it at -1, I'll store it at 0. Whatever 0 is, I'll store it at 1. Whatever 1 is, I'll store it at 2. Whatever 2 is, I'll store it at 3. Whatever n minus 1 is, I'll store it at n. I do a coordinate shift so that I am allowed to store. Understand, I did a coordinate shift so that I'm allowed to store. Okay, fine. So if I'm doing a coordinate shift, I require from 0 till n, which means if I take n plus 1, that will suffice. That's it. Just do a coordinate change. And you know how to just change it. Over here, instead of this, you write dp of index, and previous index, while storing, do a coordinate change. That's it. Plus 1 will do a coordinate change equal to length. Over here, while you come across dp of index, previous index, plus 1 is not equal to -1, then return. What I did was I just did a shuttle coordinate change and I converted this into a memoization solution. And since I converted this into a memoization solution, now what is the time complex?
Because we just changed depreciation and plus 2 only here, so it's n plus 1 here also, right? If I am doing only here, so I cannot take a like this, right, like this, and like this, right? I cannot take I plus 1, right? I think it should work now. Right. It will not go clearly to us now. Okay. Okay, now I can convert this into memoization also, because yep, vector of vector int area of n plus 1 comma vector of int comma n plus 2 here, right? So n plus 2 comma 0 link to the okay. So if the previous index is 0, right? So everything length is 0 in that case. So for int I is equal to 0, I less than equal to n plus 1, plus dp of okay, so I comma 0 is equal to 0, it's n, okay, correct. So this is the initialization, and we can go for this for int I is equal to 0, I is equal to n plus for int j is equal to 0, j is equal to n plus 1 plus right. Okay, so j is equal to -1, we can also say -1. Okay, and we can take this condition length. Okay, so if j is 1, or we can take this condition. Okay, like all of this we can take, right? Okay, so we can take this because here we were going from this 0 to n, right? No. Okay, so here we were going. So in subsequence we can do like this also, right? Okay. Tabulation, right? So we were going from 0 to that. Now here in tabulation we will go from I is equal to m minus 1 to I is greater than equal to 0 to option. Again here I is equal to m minus 1 I is greater than equal to 0 and I minus minus. Similarly from j is equal to m plus 1, j is greater than equal to minus 1 and j minus minus here, right? Now we can take these conditions as it is, interline and something like that. Okay, see here, and we will take this equal b. Interline is okay, so instead of the repeat of I plus 1 comma j, right? So we can have something like that. If j is equal to minus 1 or j is n of I current j, right? J here, then take our nums here, I plus 1 comma I. Okay, and we have equivalent dp of j is this here, and when this return we will have the button. Okay, so here what we will return? We will return dp of 0 comma 0, I think, right? Let's check it. What's happening? Okay, dp of 0 here. And time error of this. So okay, nums I and nums j is not. So nums j plus 1 always. Alright. Yeah. And here this is j plus 1 here. Okay. Right. Nums I nums j plus 1. Okay, so is just j we can see, but yeah. We can do something like that. Okay, so okay, and I told you something like that. For this we can take this
complexity. It's bgo into n, space complexity will be n into n because of the DP array that it will have index array as well as the n. Only the last thing is given clearly. Again, it's very obvious. So index plus 1 equal to this. Now you have memorized the solution. Again, every time we declare n is 10 to the power 5, right? And if n is 10 to the power 5 and you're creating a size of n cross array, 10 to the power 5 multiplied with 10 to the power 5, that's a 10 to the power 10 size array you're trying to create, and that will definitely be not possible. Thereby you're getting a runtime error. So guys, I hope in this video you have understood the recursion plus the memorization solution. So just in case you did, please make sure you like this video, and if you're new to the channel, please do consider subscribing to us. With this, I'll be wrapping up this video. Let's meet in the next.
Right, so then this tabulation method we are learning here.
Hey everyone, welcome back to Take You Forward. So in the previous video, if you remember, we did the memoization solution of the LIS video. In this video, we will be discussing the tabulation approach via the memoization, and then we will be moving across to discuss the rather bgo of n approach that you'll find in all the blocks and everything. Okay, so going back to the recursive code. Okay, going back to the recursive code. How do you convert this portion of recursive code into a tabulated code? That's a very big question. Now, if you have been following this DP series right from the first, you know the rules. The rules are very simple. Write the base case, and before that, declare the DP of the same size. So I'll declare a DP of n plus 1, and then write the base case. Now, if you look at the code, what is the base case? We just have one base case, which is if index is equal to n, we have to return a 0. So since we are declaring a DP of size n and n plus 1 and assigning everything to 0, since everything is already assigned to 0, we don't need to specifically write for the base case. I hope that makes sense. Next, write the changing parameters. So if I look at the code, these are the couple of changing parameters that we have. So write down the changing parameters in the opposite fashion. Strict rules, easy rules, which we have been following right from the start. So the index will be from n minus 1 to 0. The previous index will be from n minus 1 to minus 1. But here's a catch. If it's a previous index and it is an index, what is the definition of previous index? The previous index. So can a previous index be n minus 1 always? No. A previous index will always start from index minus 1 because it cannot be beyond index or index itself. The name itself is previous index. So this is how you can have these kind of things. So can a previous index be n minus 1 always? No. A previous index will always start from index minus 1 because it cannot be beyond index or index itself. The name itself is previous index. So this is how you can have these kind of things. The next is copy the recurrence. As simple as it can get. Copy the recurrence and make sure you follow the coordinate shift that I taught you. Follow coordinate shift that I taught you. Okay? Just make sure you do follow the coordinate shift that I taught you. So what I'll do is I will go across over here and this is how the code looks like. And over here what I'll do is I'll do a 0. And this is the index which I'll start from n minus 1, index greater than equal to 0, index minus minus, and I'll have the previous index, right, starting from index minus 1 till previous index greater than equal to minus 1 and previous index minus minus. Perfect. And now what I'll do is I will simply take this portion and I'll copy paste over here. Once I've taken this, now what I will do is I will be like, okay, let's convert this into a DP. So remember, whenever you convert it into a DP, the coordinate shift has to be done. So the second parameter will always have plus 1 because if you remember, we stored the second parameter in plus 1 state. Over here, there's the first parameter, it is as it is, and the second parameter goes into the plus 1 state. Perfect. So we move the second parameter into the plus 1 state. Over here, this will go off. Over here, this will be DP of 0, and instead of minus 1, it will be a plus 1 state. So you just do a plus 1. Once you have done this, and if you try running this, you will see that this is indeed giving you the correct answer. No, it did not. Why? Because you are at n minus 1, and you're doing an index plus 1. So make sure this is declared for n plus 1. Because n means you don't have an nth row. So just make sure you have this. So as you see, it is giving time limit exceeded because we've missed a greater than equal to over here. Nevertheless, let's put a greater than equal to over there. And this should be running fine. Perfect. So that's
Okay, so guys, I know we have been doing some mistakes here. Okay, 0 0 is right here. J is equal to I minus 1 and always. Okay, always J plus 1. Okay. Alright, let's see what happens. Okay, so no need to do this. Okay, type like this.
That's how you can convert this into a simple.
it's accepted, guys. Let's see what happens.
Sorted tabulated code. Always up +1 because if you remember, copy the recurrence. Okay, just make sure you do follow the coordinate shift that I taught you. So what I'll do is I will go across over here, and this is how the code looks like. And over here, what I'll do is I'll do a 0, and this is the index which I'll start from n-1, index greater than equal to 0, index minus minus, and I'll have the previous index right starting from index -1 till previous index greater than equal to -1 and previous index minus minus. Perfect. And now what I'll do is I will simply take this portion and I'll copy paste over here. Once I've taken this, now what I will do is I will be like, okay, let's convert this into a DP. So remember, whenever you convert it into a DP, the coordinate shift has to be done. So the second parameter will always have +1 because if you remember, we stored the second parameter in +1 state. Over here, there's the first parameter, it is as it is, and the second parameter goes into the +1 state. Perfect. So we move the second parameter into the +1 state. Over here, this will go off. Over here, this will be DP of 0, and instead of -1, it will be a +1 state. So you just do a +1. Once you have done this, and if you try running this, you will see that this is indeed giving you the correct answer. No, it did not. Why? Because you are at n-1 and you're doing an index +1. So make sure this is declared for n+1 because n means you don't have an nth row. So just make sure you have this. So as you see, it is giving time limit exceeded because we missed a greater than equal to over here. Nevertheless, let's put a greater than equal to over there. And this should be running fine. Perfect. So that's how you can convert this into a simple sorted tabulated code. Now if you're following my DP lectures right from the start, you know the space optimization technique. Yes. Whenever you see something like index +1, what comes to your brain? Yes. Space optimization. So what you do is you will just space optimize this because in order to compute index, you're just requiring the next row, just the next row. So please space optimize this by saying next row, and you can also declare a current row of n+1. If you don't understand this, it's not my fault because you're watching the DPCs right from the between. This playlist is an extension, so please make sure go back and watch all the videos because this trick I've been teaching right from the first day. So next and current. At all the index, make it current. At all the index +1, just make it next. That's the rule. At all the index +1, just make it next. And once you've done, once you've computed the entire row, just do next equal to current. Right at the end of the day, you can return current next because both of them will be same, and that's what you return. So in this way, what I have done is I have converted this code into something which is, if I show you, the time complexity is still big O of n square, but the space complexity has been boiled down to n into 2. Now, is this the best solution? No. The best.
Let's we also convert this to space optimization. Okay. Let's we have this vector of int of curl is equal to n plus 1 comma 0 comma previous n plus 1 comma 0, right, like this. Wherever it is saying like okay dp of I plus 1, right, so where we can change it to curl, and wherever it is taking curl, right, I plus 1 is previous, right, and after this one loop ends, we can make equal to curl, right, and 0, let's say like that. Okay. So this second will go off like this. Okay. Now we can this. Okay. What's happening?
Index +1, just make it next. That's the rule.
Okay, all of these are previous. Okay. Now I understand because it was in the previous. Okay, let's try it. What happened? What happened?
At all the index plus 1, just make it next. And once you've done,
Next, correct, right?
once you completed the entire,
Oh, now I understand. Now I understand. Point of I plus 1 will be there. And take. Now it will be. Okay. Previous one. J it is what do you say? I will tell you. What's what the hell? G plus 100. Plus 1. Okay. G plus 1, I plus 1. J plus 1 is there. Sorry. J plus 1. Let's check now. Okay, so it's now accepted here.
entire row, just do curve, just do next equal to curve. Right at the end of the day, you can return curve next because both of them will be same, and that's what you return. So in this way, what I have done is, I have converted this code into something which is, like if I show you, the time complexity is still big O of n square, but the space complexity has been boiled down to n into 2. Now, is this the best solution? No. The best solution uses a weird method, tabulation method. Like, I personally feel if you know this, otherwise you cannot intuitively write it. That is what I feel. So it's a tabulation method that you have to learn. It's a different way. So let's take a quick example and try to understand the tabulation method. So 5, 4, 11, 1, 16, 8. Okay, let's take this array. Okay, and now what I'll declare is, I'll declare a dp of size n. That is what I'll declare. I'll try to declare a dp of size n. Where dp of I signifies the longest increasing subsequence that ends at index I. Remember this. DP of I signifies the longest increasing subsequence that ends at index I. For an example, if I ask you, what is the longest increasing subsequence that ends with 5? You'll be like, the length is 1 definitely, because before 5, I cannot have any 1. Similarly, if I ask you, what is the longest common subsequence, longest increasing subsequence that ends at 4? Again, 5 cannot be a part of it, so you'll again say the length is 1. Similarly, if I ask you, what is the longest increasing subsequence that ends at 11? You can say 5 can be a part of it, or you can say 4 can be a part of it. Both of them can be a part of it. So I can say it can have a length of 2, because either 5, 11, either 4, 11. It can still have a length of 2, right? Next, you go to 1. Can I have a longest increasing subsequence? Anyone before 1? 5 cannot be before 1, 4 cannot be before 1, 11 cannot be before 1. So the longest increasing subsequence will be of length 1 again. 16. For 16, I can say I can have 1 before 16, so that's one of the ways. I can say I can have 4 before 16, that's one of the ways. I can say I can have 5 before 16, that's one of the ways. I can definitely say I can have 5 and 11 before 16. So these are the 4, there can be a lot of other ways as well, like 4, 16, you can figure out. But can I say the longest that I can have is if I pick 5, 11 and then 16. So I can have a length 3. For 8, can I have 16 before 8? No. Can I have 1 before 8? Yes. So 1 and 8 can be together. Can I have 11 and 8? No. Can I have 4 and 8? Yes. So I can have 1 and 8, 4 and 8, 5 and 8. I can't see more than length 2 that ends at over here. So I can still have a length 2. Thereby, I know all the longest, at 11, a length of 2 ends. At 16, a length of 3 ends. So if I know for every index, this is the possible answer. So can I say this is the LIS? Which means I can have a sequence something like 5, 11, 16 or 4, 11, 16 for that reason. I can have both of them as the length case. I can have both of them as the length. So both of them as the longest. So I can have both of them as the longest increasing subsequence, and the LIS will be the max of all DPIs, max of all DP of index, where I ranges from 0 to n minus 1. This is the formula. But the funda is, how do you compute this portion? That's important. That is the key. So you figured out what's the thought process behind this algorithm. So now let's again copy paste the same example of 5, 4, 11, 1, 16, 8. And now let's try to figure out the DP, okay? So what I'll do is have a keen focus. I know one thing for sure. Even if there does not exist any element before that, I repeat, even if there does not exist any element before that, I know the length will always be 1. The max length will be 1. He itself. So initially DP will have all the values assigned to 1 because he itself will be the maximum length. Okay. For this guy, which is index 0, for this guy, does it have any previous elements? The answer to that is no. So this will still stay as 1. Let's move to the next index. Does this guy have any previous element? The answer to that is yes, this is the previous element. But this 5 is actually greater. So this cannot be a part of subsequence. So it will still stay as 1. And I don't have any other previous elements apart from 5. Let's move next. When I move to second index, this guy doesn't have previous elements. Yes, these couple of guys are the previous elements. Can 5 become the previous of 11? The answer to that is yes. 5 can become the previous of 11. If 5 can become the previous of 11, and if there is a subsequence that ends at 5 of length 1, can I say if I involve 11, the subsequence will be of length 1 plus 1, and that will be a length 2. Because I know there is a subsequence that ends at 5 and is of length 1. So if I take that length, if I take this length, and if I add it to 11, I'll add 1 to this length, which makes it 2. Perfect. This was a previous which can combine with 11. Next previous is 4. Again, this is of a subsequence length 1. I know there is a subsequence of length 1, LIS. There is an LIS of length 1 that ends at 4. So can this be with 11? Yes. This plus 1 is 2. That is already 2. So no need to update it because I already have a length 2. Perfect. Let's move ahead. 3. So I'm moving ahead to this index. Now I have a 1. Can this be a part with 1? No. Can this be a part with 1? No. Can this be a part with 1? No. So no one can be a part with 1. So 1 will be only having a length 1. Perfect. Let's move to the next. When I'm at 4, what do I have? I have 16. Okay. Can 5 be a part of 16? Yes. It can make 5 and 16. So 5 has a length 1, adds a length 1, makes it a length 2. Can 4 be a part of 16? Yes. Length 1, adds 1, 2 is already there. Can 11 be a part of 16? Yes. I say 11 can be a part of 16. And 11 in itself is a length 2, which is 4 and 5 and 11. So this length 2 can be a part of 16, makes it a length 3. So this can be updated to length 3. Realize, since you stored the longest till 11, that helped you in attaching it and making it 1 more when it got a greater element. Got it? That's how you get 3. Can 1 be a part with 16? Yes. 2, but we already have better 1, so no need to take it. That's how you figure for 16. Next, move to the next 5. You are at 8. For 8, can this be a part? Yes. So length 2. For 8, can this be a part? Yes. Length 2. For 8, can this be a part? No. For 8, can this be a part? Yes. Length 2. For 8, can this be a part? No. So eventually you'll get length 2 only. So this is how you fill up the entire DP table. Once you have filled up the entire DP table, figure out the maximum, and that's 3. And that is going to be your LIS. That is going to be your length of LIS. So can I say, what am I doing? Can I say, I'm actually starting from index 0 and I'm going until index minus 1. That's what I'm doing. I'm starting from 0 and I'm going till n minus 1. And whenever I'm standing at, let's say, 16, I check for 5, 4, 11, 1. So I'm checking all the previous indexes. So can I say, I'm checking all the previous indexes from 0 till index minus 1. And what am I checking? I'm saying, can the previous be a part of mine? If it is, then the answer will be 1 plus whatever previous had. And I will store that in my current guy. But I need to compare that with whatever I am at current. I need to compare that. Whatever I have, and if the previous is smaller, If the previous is smaller, then just add 1 to it and then compare with myself. If it is greater, then I'll store it. At the end of the day, the max of everyone will be my answer. So without actually waiting, let's go back and try to code this out. So just format this off. And now what I'll do is I'll just declare a vector of dp of n, comma 1. So all of these guys will be declared with 1. Next, I will go from 0 and I'll go until n. I will like I plus plus. Perfect. Now I will have a previous which will be from 0. I will go until I will like previous plus plus. Perfect. Now can I say if array of previous is lesser than array of I? Can I say dp of I will be max of dp of whatever is there plus dp of previous? As simple as it can get. And once this dp of I is computed, can I store the max of all of them? I can. Well, I can store a max equal to 1 because I know that's the maximal answer. Max of maxi, comma, whenever all the dp of I is computed, and then I can return the maximum. That's how this particular algorithm will be, and it's a very straightforward one. So yeah, again, why dp? Because you're storing the previous states. That's how you can easily do this LIS. Now, if I ask you the time complexity, again, if I submit this, you'll see it'll be giving you a TLE, because the time complexity is still n square. Yeah, if I talk about the time complexity, it is still bgo of n square, but the space complexity has now boiled down to bgo of n. Now, this solution will be required if you want to trace back the LIS. If you want to trace back the LIS, this solution will be required. So it's time that we now trace back the LIS. Okay. Now we'll be learning how to print the LIS. That's very important. So let's learn how to print the LIS. So till now we have understood how to figure out the length of the LIS. But what if someone comes up and says, "Hey, can you print me the LIS? Can you actually print the LIS?" We can. What if we apply some backtrack? Can we print it? We can. So the backtrack that we will do is, what we will do is, as of now we were creating a DP array. If you remember well, we were creating a DP array and we were initially saying everyone to be 1, right? Now let's create one backtrack array, another array. Okay, you can call whatever you can just name it as hash or something others. So let's create one more array. Okay, and make sure everyone is assigned whatever index you have. Make sure everyone is assigned the index himself. So this hash array will say everyone to be 1, right? Now let's create one backtrack array, another array. Okay, you can call whatever you can just name it as hash or something others. So let's create one more array. Okay, and make sure everyone is assigned whatever index you have. Make sure everyone is assigned the index himself. So this hash array will say who was the previous index to it. You'll understand. Like for example, over here 5, it does not have any previous, so it will have 1, and it will say this 5 ends at, like, before 5 we had 5 itself, so no 1. Fine. When we reach at 4, it will. still be 1 and this 5 cannot be a part of it. It cannot be a part of it. So let's keep it as 1 and this will also be staying as 1. Now whenever we are at 11, okay, you can call whatever you can just name it as hash or something others. So let's create one more array, okay, and make sure everyone is assigned whatever index you have. Make sure everyone is assigned the index himself. So this hash array will say who was the previous index to it. You'll understand. Like for example, over here 5, it does not have any previous, so it will have 1, and it will say this 5 ends at, like before 5 we had 5 itself, so no 1. Fine. When we reach at 4, it will still be 1, and this 5 cannot be a part of it. It cannot be a part of it. So let's keep it as 1 and this will also be staying as 1. Now whenever we are at 11, what we do is we take 5, the value is 1, we add 1 and we update it to 2. Is that what we do? Definitely we update it to 2. Now remember, this 5 got before 11. Thereby this was updated to 2. So can you say 11? Before you there was 5. So at 11, can you say before 11 there was this index 0? So please store index 0. So hash will say before 11 there was an index 5. Perfect, you have told it, right? Now let's move. So we are at 11, it was 2. Now we are at 4. 4 had 1, so 1 plus 1 would have been 2. You can update it or you cannot. It's still the same value. Perfect. Next you go to 1. 1 says this cannot be, this cannot be, this cannot be. That still stays as 1. Next, you go to 16. It says that 5 can be a possible answer. So 1 plus 1 will give it 2. So this guy will be 2. So please update it 2. So what I'm saying is for the 16, before this there was 5. So let's update this to index 0. Perfect. Next this is 4. 1 plus 1 would have been 2, which is already there. Next we have an 11. It can also be a part. So this is 2. 2 plus 1 would have been 3. Perfect. Why don't you update it to 3? And if this guy is coming before 16, there is an index 2. So index 2 will be updated. Amazing. 1 cannot be an answer because 1 means 1 plus 1 is 2 and we already have a 3. So 1 cannot be an answer. Let's move to the next. We have 18. 5 can it be an answer? Yes. If I'm taking 5 as an, this was 168, not 18, my bad. Yeah. So we take 5, the value is 1, we add, we can. What if we apply some backtrack? Can we print it? We can. So the backtrack that we will do is, what we will do is, as of now we were creating a DP array. If you remember well, we were creating a DP array and we were initially saying everyone to be 1, right? Now let's create one backtrack array, another array. Okay, you can call whatever you can just name it as hash or something others. So let's create one more array, okay, and make sure everyone is assigned whatever index you have. Make sure everyone is assigned the index himself. So this hash array will say who was the previous index to it. You'll understand. Like for example, over here 5, it does not have any previous, so it will have 1, and it will say this 5 ends at, like before 5 we had 5 itself, so no 1. Fine. When we reach at 4, it will still be 1, and this 5 cannot be a part of it. It cannot be a part of it. So let's keep it as 1 and this will also be staying as 1. Now whenever we are at 11, what we do is we take 5, the value is 1, we add 1 and we update it to 2. Is that what we do? Definitely we update it to 2. Now remember, this 5 got before 11. Thereby this was updated to 2. So can you say 11? Before you there was 5. So what we do is we take 5, the value is 1, we add 1 and we update it to 2. Is that what we do? Definitely we update it to 2. Now remember, this 5 got before 11. Thereby this was updated to 2. So can you say 11? Before you there was 5. So at 11, can you say before 11 there was this index 0? So please store index 0. So hash will say before 11 there was an index 5. Perfect, you have told it, right? Now let's move. Value is 1, we add 1 and we update it to 2. Is that what we do? Definitely we update it to 2. Now remember, this 5 got before 11. Thereby this was updated to 2. So can you say 11? Before you there was 5. So at 11, can you say before 11 there was this index 0? So please store index 0. So hash will say before 11 there was an index 5. Perfect, you have told it, right? Now let's move. So we are at 11, it was 2. Now we are at 4. 4 had 1. Is that what we do? Definitely we updated to 2. Now remember, this 5 got before 11. Thereby this was updated to 2. So can you say 11? Before you there was 5. So at 11, can you say before 11 there was this index 0? So please store index 0. So hash will say before 11 there was an index 5. Perfect, you have told it, right? Now let's move. So we are at 11, it was 2. Now we are at 4. 4 had 1, so 1 plus 1 would have been 2. You can update it or you cannot. It's still the same value. Perfect. Next you go to 1. 1 says this cannot be, this cannot be, this cannot be. That still stays as 1. Next, you go to 16. It says that 5 can be a possible answer. So 1 plus 1 will give it 2. So this guy will be 2. So please update it 2. So what I'm saying is for the 16, before this there was 5. So let's update this to index 0. Perfect. Next this is 4. 1 plus 1 would have been 2, which is already there. Next we have an 11. It can also be a part. So this is 2. 2 plus 1 would have been 3. Perfect. Why don't you update it to 3? And if this guy is coming before 16, there is an index 2. So index 2 will be updated. Amazing. 1 cannot be an answer because 1 means 1 plus 1 is 2 and we already have a 3. So 1 cannot be an answer. Let's move to the next. We have 18. 5 can it be an answer? Yes. If I'm taking 5 as an, this was 168, not 18, my bad. Yeah. So for 8, can 5 be an answer? Yes. 1 plus 1. So thereby this becomes index 0. Can 4 be an answer? No, because we have already updated this to 2 while we were doing it 5. Can 4 be an answer? 1 plus 1, 2, same. 11, no. 1 plus 1, 2, 16, no. So apparently your hash array is storing something like this. And the maximum value you got was at this index 4. So you start at index 4, take up that value 16. Next, you go to the previous index. And you can easily get by hash, which is 2. So you go to 2. So at the second index, you see a value 0. So you go to 0. At 0, you see 0 itself, so you stop. So apparently index 4 has 16, index 2 has 11, index 0 has 5. So if you reverse it, it's 5, 11, 16, which is your answer. In this way, you can easily get your answer. So if I go back to the code, you just need to create one more hash array. So make sure you just...
Okay guys, so to solve this next question, right, and we can solve this question like that. Let me is it only on this? Okay, we can do it in this, right? Okay, so we have this vector and dp of size n, we can say, comma 1, we are starting everything with 1, and n equal to what we can say, array of size, right? Okay, we have overlines are equal to 0 and is the name plus for n is equal to 0 or j is less than j is equal to 0. Okay, j is less than I, j is plus so if the array of you can say what, j, right, is less than if I, then dp of I equal to dp of max of dp of I, comma 1 plus dp of j. Correct? Alright, this is how, and we will have also one vector of the integer dp of n comma 0 and is equal to 0 I less than n plus this is like plus, we can say s of I into I, right? Okay, like that. Yes, right. Okay, so in that case, when this is array of I doing this, in that case what we can do is of I in G, and after that what we can do, okay, we have a vector of int of answer, right? Then in this answer what we can have, okay, so while index is greater than 0, we can say then let's print I is the HASS of IDX, right, and answer dot push back. I think here I'm doing right. Push back. I and IDX is equal to okay, and return answer. So should I sort this out? Yeah, because sort answer dot begin answer dot this do this. Okay. So while IDX equal and IDX is equal to n minus 1. That is so it's the same interval. Let's see the value here.
Hey everyone, welcome back to Take You Forward. So in the previous video, what the next step is, just go across whenever this is getting updated. So instead of writing this, you can simply write and whenever this guy is greater than dp of I know I'll update this to this portion. At the same time, I'll say hash of I to store the previous guy. Perfect. And over
so what is this saying? Like okay, if previous of this is one condition. If 1 plus dp of previous is greater than dp of I, okay, then we upload this. Alright. If one more condition, if this and 1 plus dp of j greater than dp of I, then we can update. Okay, so one thing is the same thing, I think, right? It's the same thing, there is no
over here, you can definitely keep the last index as 1, as 0 initially, and whenever dp of I exceeds maximum, you can simply say maximum to be dp of I and the last index to be I. So
okay, so and if dp of I is the next, okay, we have to do this also. Okay, alright. So here enter, right, and the next equal to 1, and after this formula, if dp of I is greater than c, right, then we max equal to depth I and last equal to max I. Into last let's last
So you've stored the last index. Now what you can do is you can simply like take an index which is like you can just go on till while hash of last index is not equal to last index. In this way you can just bump up, and over here probably you can say int alias, and you know this is the length.
Okay, so what is the problem? This one is wrong answer. Only output 10, 20, okay. Now that is it is equal to 0. Then I can say it here. While the index okay. जीरो तो रहेगा ही ना भाई. Zero. So we can say break. This will not be like this. You can say this one, or you can say here. We can take this here. Okay. So 10, 10, 20. What is the problem in this? Let me ask you the guru now.
Right, and alias of 0 will be nothing but array of last index, that's the last guy. And over here what you can do is you can say last index to bump up to hash of last index, and you can say alias of, like you can probably keep an index equal to 0, index equal to 1, because the first index has been done. So index equal to whatever is at the last index, you can easily take it, and you can bring 5, 4, 11, 1, 16, 8, and
Let me ask you here. What is the thing? Just count the combination product using hash array. You are laying down mathematical breadcrumbs to be able to trace a primary element. However, most element grab and infinite loop also. Okay. What is the bug here? You are at the final period chest. Your map has the chest is location I. Instead putting the treasure right now. You will reach back in time and grab the previous treasure I. You completely left the final largest number in hand. At any state K, you must append the value K and then update your state to K minus 1 hash K. Okay, but origin point to finite loop, how do you reach the beginning of the so your find itself. If you valid second greater than hash with 3, it is colon. If you okay, so let's 1 hash and 0. Okay, I have evidence for next one as the drop the broken point in the course to J. Okay, then if dp of I greater than maxi into I and vector answer possible answer last. Okay, so always push the element we are currently standing on. Okay, we are pushing that. Then mathematically check if we are at the origin point, right, which has last is equal to time. Okay, last is equal to hash last. I think I need to do this. See, this I didn't need to sort that. I need to reverse that. Wow, what? Yeah. We and this will be the last. It's reverse, right? This one I can submit it now. Yeah, successfully submitted. Thank you so much. Also, I have done this here. One more is this. What is this single use of sequence? We haven't done this here. Okay, why is this so? Let's watch the video. Why it is like different here?
Hey everyone, welcome back to Take You Forward. So today we will be solving the problem longest increasing subsequence using binary search. In the previous two videos we have solved using recursion, memoization, space optimization, tabulation and an algorithmic approach. These approach has been covered in the previous couple of videos, but we did see that the constraint was n equal to 10 to the power 5 and the best we could do was time complexity of big O of n square and a space complexity of big O of n. This was the best that we had done till now. But if n is 10 to the power 5, n square is 10 to the power 5 square is 10 to the power 10 operations, which is definitely giving you a TLE. So we definitely cannot do this, right? So that's where something like binary search comes in. Can we find LIS using binary search? Now you'll find a lot of videos where the intuition is missing. Like I went through a lot of videos, but the intuition was missing. So in this video, my main focus will be to give you the thought process, because once you get the thought process, the algorithm is very, very simple. So prerequisites are you should be knowing binary search, and there is a lower bound and there's an upper bound video in my channel. I'll be putting the link in the description. Go back and watch it, and after that come back and watch this video. Okay. If you know lower bound, it's well and good. So let's get started. First of all, what is LIS? You know what is longest increasing subsequence? Like you can call a subsequence like 1, 8, 4, 6. This is a subsequence, not increasing. You can call something like 1, 8, 9 as an increasing subsequence. Increasing, okay? Similarly, you can call something like 1, 4, 5, 6, 9 as the longest increasing subsequence of length 5. Subsequence, you know, a contiguous or a non-contiguous part. But it should follow the order. Like you can't be like 1, 8, 7, 6. This is not a subsequence because 8 is before 7, but actually 7 is before 8. So this is not a subsequence. Okay, so we saw that the longest increasing subsequence over here was 1, 4, 5, 6 and 9. Okay, so how do you actually solve this particular problem? That's a big. So how do you approach this problem? So what I'll say is, okay, let's try to go across every element and try to form subsequences. That's my thinking. So I'll be like, okay, initially when I'm at 1, okay, let's form a subsequence with 1. Makes sense. Next, let's go to 7. Do I need to form a new subsequence with 7, or can I just attach it over here? The answer to that is, let's attach it over here. Why? Because if you form a new, it will be of length 1. But if I attach it, it is still increasing, and it is having a length 2. Perfect. Let's move to 8. Now, if you're having 8, can you attach it over here, or will you prefer this? You can, because because 8 is before 7, but actually 7 is before 8. So this is not a subsequence. Okay, so we saw that the longest increasing subsequence over here was 1, 4, 5, 6, and 9. Okay, so how do you actually solve this particular problem? That's a big. So how do you approach this problem? So what I will say is, okay, let's try to go across every element and try to form subsequences. That's my thinking. So I'll be like, okay, initially when I'm at 1, okay, let's form a subsequence with 1. Makes sense. Next, let's go to 7. Do I need to form a new subsequence with 7? Or can I just attach it over here? The answer to that is, let's attach it over here. Why? Because if you form a new, it will be of length 1. But if I attach it, it is still increasing, and it is having a length 2. Perfect. Let's move to 8. Now, if you're having 8, can you attach it over here, or will you prefer this? You can, because 8 is still greater than 7. Perfect. It's still greater than 7. So I've attached it. Next, I go to 4. So I see there is 4. But if I attach it over here, it will not be increasing, because 8 is greater than 4. It will not be increasing. So I can either start with 4, but my brain says, but Striver, there is one which you can take and you can attach with 4. So I'm like, okay. Makes sense. Next, I go to 5. The moment I go to 5, can I attach it here? The answer to that is, no, Striver, you cannot. Can I attach it over here? Yes, Striver, you can. Perfect. Next, I go to 6. I have a 6. Can I attach it over here? No. Can I attach it over here? Yes. Perfect. Next, I go to -1. Where can I attach it? Now, my brain says, we can't attach it. We cannot attach a -1 here. We cannot attach a -1 here. But we can start fresh. Will -1 have anything before? No. It's the smallest. So I will have -1 right before this. Perfect. Next, I go to 9. So when I go to 9, I can attach 9 here. I can attach 9 here. I can attach 9 here. So, assuming I attach to everyone, it's over. So once you end it, you see this is a length 4. You see this is a length 5. You see this is a length 2. And eventually, the length 5 is the longest one, and that is the length of the alias. But will you actually go across and generate all these subsequences? Because it's going to be very hectic, and it's going to be taking a lot of time, because if you make new subsequences at every junction, it's going to take up a lot of space. Because if you're aiming to make a new subsequence at every step, it's going to take up a lot of space. So we will definitely not move this way. But this is an intuition which helps us to think of binary search. So tell me one thing, like I don't need to print LCS. I just need 5. So can I do something like this? When I was carrying 178 and this was done, when 4 came in, can I say 178, let's rewrite 4 over here. Can I do something like this? Rewrite the same subsequence. Can I do something like this? And the answer to that is yes, Striker. We can do it. And let me show you what I'm actually talking about. Because we're just concerned about the length. We are at 1. Let's have 1. We are at 7. Let's have 7. We are at 8. Let's have 8. We are at 4. Instead of making 1 4, since we are actually not concerned about the alias and we're concerned about the length, we will say, where can 4 fit in the existing subsequence? I say 4 can fit in here. So what you do is, remember, you take the 7 out. And you say 4 can fit in here. Remember this, that it does not mean 148 is a subsequence. No. I'm just making sure instead of storing 1 4 separately, I stored 1 4 right over there to save space. Even if someone like 9 comes in, and because I know if 8 is there, why is 8 here? Because previously 7 was there. That's the reason 8 is here. That is something which we definitely know. So we are sure that before 8 there is something smaller, which is 7. Yeah, we have overwritten it, but we are not concerned about the subsequence. That's why what I did is, instead of creating a new, I overwrote the 7. I overwrote the 7 to 4, because it's okay to overwrite, because we're not concerned about the alias, we're concerned about the length. So I overwrote it at that place itself. Perfect. Let's move across to the next, which is 5. Okay, where can 5 be? I either go and create like 1 4 5, or I either say let's not create, and instead of that, let's omit 8 and write 5. Because either you're carrying 178 or either you're carrying 1 4 5. It still makes the same sense, right? Perfect. Let's go to 6. The moment I go to 6, I'm like, okay, fine. Where can I have 6? Right after this. Amazing. The moment I have -1, where can I have it? I can definitely have it right over here. Replace it. So I replace it over here, saying not 1, it's going to be -1. Perfect. Where can I have 9? I say right after this. So this is not the subsequence. This is definitely not the subsequence, but this gives you the length. The length of the final array will be your answer, which is 5. Because you replicated by putting those values. You replicated the same space by putting those values. That's how you can easily do it. Now, why binary search? Again, very straightforward. If you if again just omit this off, I'll be just omitting this. Why binary search? Again, a very simple one. Because initially you had 1, then you had 7, then you had 8. The moment you got 4, you want to insert 4. If there is a 4, you insert it at that place, or you say, hey, listen, there is no 4, so please go across and insert it right after 4, right at the first element after 4. At the first element after 4. Can you please do it for me? Right at the first element after 4. So since you know this is sorted, in order to insert 4 here, you can simply do a binary search, and binary search will say 4 will go here. Next you go to 5, binary search will say first element after 5, that's 8. Binary search will say I'll go here. 6, first element after 6, no one, so goes here. First element after -1, that's this. First element after 9, that's this. That's how you get the length. That's how you replicate. That's the thought process, simple thought process behind the binary search solution. So in C++, there exists a function like lower bound. Like you might argue, okay, let me just give you one more example. If array is given something like 1, 4, 5, then a 4, then a 2, then a 8. So what will happen in this case? Because you see repeated elements. So initially you are at 1, so you don't have anything, so you put it across here. Perfect. Next you have a 4. Yes, next you have a 4. So you again right after 4. So that's where you put. Next you have a 5. You put here. Now when you look for 4 again, if there exists a 4, you just rewrite it over there, because that's what you do. You don't put it across anywhere else. Next you give a 2, so this is where it goes. Next you get 8, this is where it goes. So this is the length. Length is going to be 4. Again, is it practical enough? Yes, because 1, 4, 5, 8 can be the subsequence. Can you regenerate the subsequence via binary search? The answer is no. Then you have to store a lot more things. But you can easily get the length by accessing the length, because you optimize space. Instead of carrying different subsequences, you reuse that space and you created it. So it's time to actually now go back and code it. So in order to remember this, our main intention of binary search is if there is an element as array of I, find array of I. Like in this case, if you see, when I inserted 4, I inserted at the place of 4. I inserted at the place of 4, right? So either find array of I, and if this is not found, find first greater, again the first element that's greater than array of I. That's it. And in C++, this can easily be done using a function, a lower bound. The lower bound, if you are doing a lower bound on any array, it gives you the first index, it gives you the index of array of I if exist, or gives you the first index which is greater than array of I. In order to understand it in depth, you can watch the video link in the description. Okay, so guys, it's time to check out the code now. So in the iPad, if you see, there is 1 initially, right? So what I'll do is I'll put this 1 into some temporary. Okay, temporary. So as I can know that, what I'll do is I'll just declare a temporary. That's the initial stuff that I'll do. And let's put the first guy into the temporary, because I know that's where I start off. So array of 0 will go in. And now I can initially start from I equal to 1, and I can just go until I plus plus. Okay, perfect. Now whenever in the next step I get 7, what do? I just take 7, add it. Next time whenever I get 8, I add it. Why? Because 7 was greater than 1, 8 was greater than 7. So just make sure if this guy is greater than the last guy, if this guy is greater than the last guy, don't do anything, just go across and say, hey, listen, can you just go across this guy? That's perfect. If it is not, then you need to put a binary search on the index. So in the index, you can easily do a binary search like lower bound, and the temporary space is this. So just do comma temporary dot end, and you're looking for array of I. That's what you'll do a binary search, and you can just subtract 10. That's how easy the binary search will be looking. Perfect. Once you've got the index, just go to temporary index and say this is where this guy will replace. Once you've done this, you can directly return the temp dot size. Perfect. And in this way, if you run this code, it should be, I think it should give you the correct answer. My bad, temp dot begin. This will be temp dot begin. Now it should give you the correct answer. So we did a mistake. This will be array of I, and yeah, it should be fine now. And you see all the test cases are running absolutely fine. Like this will take some more space. So what you can do is you know every time you're pushing, this is like the initial length is 1, and every time you're inserting 1, the length will always increase. So yeah, that's how you can also maintain the length of the alias. And you can just run this like, I don't want to do a temp dot size right at the end, because inserting 1, the length will always increase. So yeah, that's how you can also maintain the length of the alias. And you can just run this like, I don't want to do a temp dot size right at the end, because it might end up taking a bit more space. So a bit more time rather. So now if I submit this, you will see that this is indeed running absolutely fine. Yeah, this is how you get the 100% solution. So guys, what was the time complexity that we did use? It was big O of n
okay, sir, we can do this like, okay, we are vector of int which is 10 declare, and for int I is equal to 0, I less than nums dot size, right? I plus plus if nums dot I is greater than nums dot I greater than nums wait what? Okay, temp dot back, right? And what we do, temp dot push back, back of nums of I, which is not the case, right? Else what we do, we check index is equal to lower bound in temp dot begin, right, comma temp dot end, I, right, index. Then what we do, temp of idx is equal to area of I, right, and here I plus len plus plus temp dot push back, area of 0. First we have to use the first element here, into len equal to 0. We can say 1 here, right, and in this case turn len. Is there any, we can cross this like that, okay, right, whatever. Oh, it's not area, so no, zero. What do you mean? Is there any error? Okay, it's no surprise, it's all nums, right, okay. Whatever. What's happening?
Hey everyone, welcome back to Take You Forward. So today array of I, that's what you'll do a binary search and you can just subtract them. That's how
Stuck in below the circle, I think this okay. Yes, we include let's and let's how about that? Okay, I think it's asking for this. Alright. Now again, what's happening is, okay.
how easy the binary search will be looking. Perfect. Once you've got the index, just go to temporary index and say this is where this guy will replace. Once you have done this, you can directly return the temp.size. Perfect. And in this way, if you run this code, it should be, I think it should give you the correct answer. My bad, temp.begin. This will be temp.begin. Now it should give you the correct answer. So, and in this way, if you run this code, it should be, I think it should give you the correct answer. My bad, temp.begin. This will be temp.begin. Now it should give you the correct answer. So we did a mistake. This will be array of I, and yeah, it should be fine now. And you see all the test cases are running up.
Okay, so it's like we are okay, like that. Are you saying this?
Can directly return the temp.size, which will be looking perfect. Once you've got the index, you can easily do a binary search like so. You'll do a word bound, and the temporary space is this. So just do a begin, comma temporary dot end, and you're looking for array of I. That's what you'll do a binary search, and you can just subtract temp. That's how easy the binary search will be looking perfect. Once you've got the index, just go to temporary index and say this is where
okay. Now it's accepted as what the hell. I don't want to do it. I already done this, so no. I'll do this list. So far. And vector input nums what is it? just like that. This here also. So we've done this. Largest division subset. Let's try this. What is this? Okay. So it is saying you are given a set of distinct positive integer nums, and what you have to do, you have to return the largest subset answer such that every pair answer I answer G of element in the subset satisfies. Alright, so let's try this, guys. What is this saying? I think it's similar to increasing, right? Let's try it also. Okay, Control V here. What did it say? It is saying like you are given a set of distinct positive integers nums, right? Return the largest subset answer such that the every pair answer I answer G of element in the subset satisfies. So answer I answer J is equal to 0 or answer J is 0. If there is a multiple solution, return any of them. 1, 2, 3, return 1, 2, like so 1, 3 also accepted. Okay, so 1, 2 and 3. 1 divide 2, okay. Take this. Or we can do what? If it does not divide, we can go here. Like increasing instead of increasing, we do divisibility. Right. So yeah, it's simple. Subset or subsequence, it is simple. We have this. Okay. So we will have this function which is int. Do we have to okay, so I have to give this. Alright. Okay, so first do the recursion part, right? Recursion, can we do the recursion? I think I should watch the video for easiest part, but I can do this with the, we can find the length, but to print that, we can have this vector of indexes which says has, yeah, and recursive also, and we can print this later. Okay, so what we can do is vector integer of all has of size n comma what, comma you can say 0, or we can say comma 0 for int 0 I is less than n equals to less has of I equal to I, just like this I equal. And what is n here? You know, and n is equal to I no nums dot size, right? Okay, this is nums dot size. and we are okay, we have a function, we don't have to return that, right? Okay, we also can have this array like called return of int. Okay, so int here int dt of n comma 0 here, right? And what we can do is, let's do n square first, right? Okay, for I equal to 0, I less than n, or equal plus for n to j equal to 0, j less than I, j plus, right? Just like that. Okay, and what we can do, go from like here to here. Okay, so we have to decrease as used to 1 because all them is like that. Okay, so if array of I right, divide means what? Modulo. If completely, yeah, modulo array of j is equal to 0, then it divides it, right? And what? So I have to take a subset, right? So 1, 2, 3, is it sorted? So every pair, right? Okay. So how can we do that, guys? Let's do one thing. Watch the video and go ahead with it.
Hey everyone, welcome back to Take You Forward. So today we will be solving the problem largest divisible subset, which is DP44. But before this, DP41, DP42, which is based on longest increasing subsequence, should have been done because we are following the pattern of longest increasing subsequence. So if you know this, then only solve this problem, otherwise not. So let's first understand the meaning of subset. As of now, we were doing problems which are longest increasing subsequence. Now I'm calling subset. The definition of subsequences, I can pick 1, 16, 8, and they have to be in the same order as in the array. They have to be in the same order as in the array. That is what we call generically as subsequence. But the moment I attach the terms subset, I can write them as 1, 8, 16. 1, 16, 8 is also a subset. 1, 7, 16 is a subset. You generally don't need to follow an order. You can pick up any element from the array and you can write. So if you're not following the order and you're picking up any element from the array and you're writing it, that is what we call as subset. Now what is the definition of divisible? Now if you have picked up a subset, all the elements in itself, if you pick
नौसेना में चयनित होकर पहली बार गांव लौटने पर ग्रामीणों ने रोहित का ढोल नगालों, डीजे और फूल मालाओं के साथ जोरदार स्वागत किया। गांव की सीमा में प्रवेश करते ही देश से सेवा का जज्बा लेकर लौटे रोहित ने सबसे पहले प्रसिद्ध बिहारी हनुमान जी मंदिर पहुंचकर शीश नवाया। उन्होंने बजरंग बली की पूजा अर्चना कर देश सेवा के अपने नए सफर के लिए आशीर्वाद लिया। इस दौरान उनके साथ भारी संख्या में स्थानीय ग्रामीण और युवा मौजूद रहे, जो रोहित के समर्थन में नारेबाजी कर रहे थे। रोहित की सफलता पर उनके कोच मुक्कन पहलवान ने खुशी जाहिर करते हुए क्षेत्र के युवाओं को एक विशेष संदेश दिया। उन्होंने कहा, रोहित की यह सफलता क्षेत्र के अन्य युवाओं के लिए चयन होने
रूटीन एरिया क्रैप सब बोलते हैं जॉग को। जॉग होती है लीच, एक एनिमल होता है ऐसे पानी में
So any two elements, they should be dividing each other. Like if I pick up an element array of I and array of j, so either array of I should be dividing array of j, or either array of j should be dividing array of I. It should satisfy either of these conditions. For an example, subset. Now what is the definition of divisible? Now if you have picked up a subset, all the elements in itself, if you pick up any two elements, they should be dividing each other. Like if I pick up an element array of I and array of j, so either array of I should be dividing array of j, or either array of j should be dividing array of I. It should satisfy either of these conditions. For an example, if I pick up a subset like 16, 8, 4, this is a subset. Now what can be all what all pairs can I have? I can have 16, 8 as a pair, I can have 16, 4 as a pair, I can have 8, 4 as a pair. Like I can have 16, 8, I can have 16, 4, and then I can have 8 and 4. Right? So these are the three pairs that I can have. Now if you carefully see, 16 is divisible by 8, 16 is divisible by 4, 8 is divisible by 4. So every pair is divisible. I'm not saying that 8 has to be divisible by 16. It can be either way. 16 is divisible by 8, that's okay. So that is the meaning of divisibility. That's the meaning of divisibility. So I need to find the largest. So I can say if I just omit this, which will be the largest divisibility pair, then I'll be like, I can pick 1, 16, 8 and 4. This is indeed the largest divisibility pair, because if I write down the pairs, 1, 16, 16 divides 1 for sure. That's the meaning of divisibility. So I need to find the largest. So I can say if I just omit this, which will be the largest divisibility pair, then I'll be like, I can pick 1, 16, 8 and 4. This is indeed the largest divisibility pair, because if I write down the pairs, 1, 16, 16 divides 1 for sure. 1, 8, 1 divides 8 for sure. 1, 4, it's still divisible. 16, 8, divisible. 16, 4, divisible. 8, 4, divisible. So I can say all the pairs are divisible. Okay. So if all the pairs are divisible, this can be a possible answer. And if you add a 7 to it, this will not. Why? Because if you add a 7, the 7 is not divisible by 4, 8, 16. So you need to be very sure that each of the pairs are divisible, which are in the subset. So divisible divisible you have understood. Now about largest. You have understood this is the largest. This is of size 4. And you cannot have any greater size subset. Now the question states the array that you are given will have distinct numbers. The array that you will have distinct numbers. Okay, that is for sure stated. And also another statement is given to you that you can print any answer. Since we're talking about subset, you can print 1, 16, 8, 4. You can jumble it up and print like 4, 8, 1, 16. Or you can also print it like 1, 4, 8, 16 in the sorted fashion. You can print any of the answers. And if they are dividing each other, you will be getting a AC, which is correct answer. Got it? So that is what the problem is all about. Now since they're saying, so print any answer. Here lies a possible thought process. Since they're saying print any answer, and we are looking for divisibility, we need to convert this problem into somewhere related to longest increasing subsequence, because we know in dynamic programming it's generally the subsequence where we deal with indexes and then we decide whether to pick or not pick. We generally know that. So can we relate this to somewhere around longest increasing subsequence? I'll be like, how? I'll tell you that. What if I take this example and I try to sort it? Because since I can print any answer and the order does not matter, even if I sort it and I try to find out an answer, it is still okay. As long as the divisibility is not compromised, I'm still okay. So I'll be like, okay, straight, let's definitely sort it, because it doesn't matter. Even if I sort it, whatever answer I get, like even if I get 1, 4, 8, 16, that's still okay. Okay, fine. Now, how do you make sure that each of the pairs are divisible? Like, how do you make sure that 1 divides like 16, 1 divides 8, 1 divides 4, and then 16 divides 8, 16 divides 4? Can we have a shortcut to it? Now, since I have sorted it, again, please hear me out properly. Since I have sorted it, okay, if I'm picking 1 as my first guy, and the next guy I pick up 4, and the next guy I pick up 4, okay, and then I say that, hey, listen, 4 is divided by 1, right? So if I'm picking up 8, the next guy, because I cannot pick up 7, because 7 cannot be divided by 4. This is not possible. But can I pick up 8? Why? Because 8 is divisible by 4. Can I say this? If 8 is divisible by 4, which eventually means that 8 is also divisible by 1. Because 4 is divisible by 1. So 8 has to be divisible by 1. Understand the intuition. If 4 is divisible by 1 and if 8 is divisible by 4, so the rule also follows that 8 will be divisible by 1, right? Okay, next I come to 16. Now can I say, when I come to 16 and 16 is divisible by 8, which indirectly means 16 is divisible by 4 and 16 is divisible by 1 also, due to the sorted, because I've already checked for the divisibility of 4 by 8 and divisibility of 1 by 4. So I can easily say 16 if divisible by 8 means that divisible by all the elements in the array. So I can say, I can easily pick up 16. So did you find the pattern? Did you find the pattern? You did. Whenever I'm picking up 16, since the array is sorted, I'm definitely sure if 16 divides 8, like if 16 is divisible by 8, it will be divided by all the other picked up elements. Why? Because 8 is divisible by 4, which eventually means that 16 is divisible by 4 as well. So the rule. So you can try out another example and you see. So I got this. So can I say, now I'm looking out to figure, like can I just think this question as, once I've sorted the question, am I looking out to figure longest subsequence? And can I say divisible subsequence instead of increasing? Am I looking to figure out the longest divisible subsequence? And answer to that is yes. Why? Because 4 divided by 1, true. 8 divided by 4, true. 16 divided by 8, true. Right? Prior to this, we were solving a problem which was increasing, like we were taking 1, 3, something like 5. This was longest increasing subsequence. Can I relate this problem to longest divisible subsequence? Instead of increasing, I'm making sure the next number that is being picked, has to be divisible. So if you remember the code for LIS, you remember, you do. So if I just rewrite the code, it was something like I equal to, it started from 1 because 0 will be not there, I lesser than I plus plus, and if you remember there was a J loop which was from 0 till I, and you went on till J plus plus, and since it was increasing, you said if array of J is lesser than array of I, because you're saying array of I, LIS, plain LIS. And at the same time you said if DP of I, whatever it had was lesser than if I take this element, because if I take this element it will be plus 1. If it is, then you went on and said DP of I will be DP of J plus 1. And you said in the hash of I, you can keep J because that's where the DP would have been derived from. This is the if statement. This is the if statement that you wrote, and then the for loop executed. So if you remember, this was the LIS. If you remember well, this was the LIS code. And the LIS code, you checked for this, and that's how you stored the hash. Now I'm changing the question to divisible. Once the array is sorted, I've changed the question to divisible. I just need to check for divisibility. So can I say, because I know the array is sorted. So can I say, what I just need to do is, I need to cut this guy off, and I know array of I is greater. So if array of I is divisible by array of J, then I can say it's divisible. And then I just need to check for the length, because I'm looking for the longest. So this is how the length of DP will work. Slight shuttle change, and I could convert an LIS question to an LDS, which is the longest divisible subsequence. Make sense, guys? So once you've done this, you can definitely use the hash array to track back. Yes, you can use the hash array to track back your longest divisible subset. And since you need to print any we did, we basically took up a vector DP, and basically let's copy paste this. It's the same code. So I'll just copy paste this over here in the divisible set question. So just copy paste it. So if you remember, this was the DP and this was the hash, and initially the maximum was 1. I've taken the exact same code. What I will do different is, I will say, I will sort the array. Okay, I will sort the array. Nothing different. I'll just sort the array. Once I've sorted this, instead of this, I will say if array of I modulo array of previous is equal to 0. If this is true and this is kind of true, then this is what I write, and in this way I can store it. And this will make sure the subset is stored, and I can reverse it, and I can just make sure over here they want the subset to be returned. So just return the subset. So that's how you can do it. Just a shuttle change. And if you try running this,
okay guys, so let me write this code here. Then write. Just sort the nums. Nums dot begin. Nums dot end here. Right, and okay, and so what we can do, if it is divisible, then DP of what? DP of I is equal to max of DP of I comma 1 plus DP of J, right? And what we can say is like has then has of I, right, into J. Okay, and if it is not divisible, then else what we can do? Is there anything to do when else condition?
they want the subset to be returned.
Okay, let's check. Okay, like this only. We don't have to check the else condition. DP of I max. Okay. last into maxi equal to 0, or we can say 1 also, into last is equal to 0, right? When this entities, if maxi is less than dp of I, then dp of max is equal to dp of I, right? Max length, and the last index is last is equal to I, right? Okay, after that, after all of this, what we do, answer dot push back here dot last, right? And okay, and what we can do is int dx is equal to last, while s of idx is not equal to index, and then what we do is okay, so idx is equal to s idx, and okay, then answer dot push back here of dx, right, like that, and so yes, we return the answer. And what is answer? Answer is just int just a vector int answer, just like that. Alright, let's check what happens here. Okay, whatever error, it's all none, so wow, it's again this thing, right? What we can do for this? Okay, let's do nothing. Means okay, here also means means here, okay. Okay, means let's check. Okay, I think it's working, guys. Wrong answer for what? Did I sort it or not? Yeah, let's check what is the code he has.
And this will make sure the subset is stored.
And this will be the last index. Okay, the size is equal to j, which is correct. And while the last index, this is equal to last index. This is the rest of last index. It is last index here.
And I can reverse it, and I can just
I have to reverse it also. Wow.
make sure
Reverse
over here they want the subset to be returned. So just return the subset.
Okay, so I have to reverse that one. Right. Here I have to reverse answer dot begin and right. Let's check now. Again wrong answer. Okay, so I expected 4, 8, 16 only. You have included 3 also. Okay, why is this so?
So that's how you can do it. Just a shuffle change, and if you try running this, you will see that it is indeed running fine. But that n was not declared in the scope because they did not give you n, so probably you can just go across and declare it. Another thing will be hash include is something which is again missing. Hash include bits / stdc plus h. That's what
Okay, justify is I, which is all fine. There is 0. Okay, less than I.
again has been taken. But now let's run the code. So you see, all of them are giving correct answer. So easy, isn't it? So if you submit this, it will give you correct answer. So what is the time complexity, guys? It will be n square for these couple of loops. So the time complexity is n square, and then you're tracking back. So at the worst case,
So let's check this. Group, I think what's happening? 1 and comma 0. Okay. And initialize. Okay, so I didn't initialize it with this for loop. Where is the for loop? I can say s is equal to I first, okay, then everything. Okay, I think it should work now. Again, wrong answer, guys. Now 45 running 10, 24, expect to 48 to 5. Okay. Now what else? 10 and 250. Okay, so it's not about max and dp of I is less than 1 less dp of j. Whatever. Yeah, and like this. What do you say now? It's accepted, guys. Okay, so let's get back to this longer substring chain. We will check it later.
hey everyone, welcome back to Take You Forward. So today we will be solving the problem longest string chain, and this is the DP 45. Again, the prerequisites are very simple. You should have seen LIS. If you have not, go and watch out 41 and 42. DP 41 and 42 are the prerequisites for this. If you have not, you'll not understand this. And after that, don't tell me that you did not. So what is the problem? Longest string chain. So I'll be given an array of words. I'll be given an array of strings, which will be words. So this is it. Now you have to figure out the chain, string chain. What does that mean? I can say A, DA, and then BDA. This is a chain. I can say A, BA, BCA. This is a chain. I can say B, BA, BCA is a chain. What do you mean by chain? This can be anything. The first guy can be anything. It is not a compulsion that it has to be a single character guy. It can be any word. After that, if you insert one character, you get the next word. So if you insert B, you get BA. After that, if I insert D, I get BDA. And the insertion can be done anywhere. Like if I insert D in between, I get BDA. Similarly, if I insert B, I get BA. Similarly, if I insert C, I get BCA. I insert A, I get BA. I insert C, I get BCA. So that is string chain. If you are talking about this, the previous guy should be one deletion. If you're talking about this, the previous guy should be one deletion. So that is what string chain is. You can call this in the chain if you've just added one character, or if you've just added one character in that word at any given place, then you can call this a chain. But whenever I attach longest, it means you find the longest among all the chains possible. Okay, so which will be the longest chain? Can I say if I pick something like A, BA, BCA, and after that BDCA, do I see? Yes, because I can just add a B and I'll get BA. I'll just add a C, I'll get BCA. I'll just add a D and I'll get BDCA. So can I say the longest is A, BA, BCA, BDCA, and the length is 4. So the question states you to print the length 4. Even you can print the sequence if you wish to. Once we will be doing this, you can easily do it. So I want you to print the length, the longest length. So how do you solve this particular problem? That's the point. So can you relate this problem to somewhere related to longest increasing subsequence? Let's relate. So what was longest increasing subsequence? This was saying it is subsequence. Now, does it match? This is a longest string chain, or I can say string subsequence, which is again a good word. So subsequence and subsequence does match. Longest and longest does match. Only problem is string and increasing. In LIS, if you remember, it was like 1, 4, 3, 7, 10. Then I was like, okay, this. Why? Because this is greater, this is greater, this is greater. We were saying greater. Over here, strings are part of it, because instead of greater, can I say the difference is one character? The difference between them is one character. The difference between them is one character. So can I say, instead of increasing, if I can check the difference to be one character, then the question is pretty much similar. Indeed. So if you remember the LIS code, it was pretty straightforward. You started from somewhere like 0, like 1. You went until n, and the j or the previous loop started from 0 till I, and you went in like j++. And if you remember, the code was quite straightforward. If array of I was greater than array of j, and dp of j plus 1, because that was the sequence, was greater than dp of I, you ended up saying dp of I will be dp of j plus 1, and that's how you changed. So this was the code for LIS. Now I'm looking for a similar structure. I'm looking for a similar structure of subsequence. But the problem is, when I have two strings, prior to this we had two guys like 4 and 7, and we compared if 7 is greater than 4. Over here, if we have two strings, assumes array of I is a string, array of j is a string. Can I say I just need to compare if they are differentiating by one character? Can I say I need to compare them if they are differentiating by one character? If they are, can I say it's going to be the same problem? Instead of increasing, I just need to make sure if I'm taking BCA and the previous guy is BA, then it should be just an addition of character which makes BCA. That's it. That is what I need to compare. So if I can write the compare, I think my problem will be solved, and I can get the maximum, like I can just get the maxi equal to max of maxi, comma, all the dp of i's, and I can say that's my answer. And I can return the answer to be maximum. So the shuttle changes over here. If you can compare array of I and array of j, and you see that they're differentiating by one character, like you can form array of I, which is the word, by inserting one character on array of j. That's it. That's what you need to check, and that's pretty simple, very easy. It's not that tough. So if you can do this portion, I think our job will be done. Now, assuming I take BDA and BDCA, assume the array of j is BDA and the array of I is BDCA. This is definitely possible. Why? Because if you insert a C, you get BDCA. But how do you write that function to check? It's very simple. What you do is, you write BDCA, okay? You keep a pointer I over here, and you write BDA, and you keep a pointer J over here. Quite straightforward. Instead of I and J, let's just mark it as pointers. Are they matching? They are. Just move the pointer. Are they matching? They are. Just move the pointers. Are they matching? No. Just move the pointer. Remember this. The C did not match with A, so you just moved A. You just moved this pointer and not this. Are they matching? Yes. Just move the pointer. So at the end of the day, you see, if this guy reached the end, and if this guy reached the end, if both of them reach the end simultaneously, it's very important, simultaneously, then we can say they're matching. But do we have any other cases? Let's see for a case where it's not an insertion at the end. Assume array of j, like the previous guy, to be BC, and array of I, or rather BCD, to be BCDA. This is possible, because if you insert A, this is possible. So instead of checking this, you're checking, is it possible or not? Now what you do is, you say BCDA, let's keep a pointer. BCD, let's keep a pointer. BB matches, let's move. CC matches, let's move. DD matches, let's move. Over here we are at A. A does not match, so let's move. So if at the end of the day, again, you have simultaneously, you have reached the end for both the strings, it is indeed sure, it is indeed possible. So if it is possible, that's how you can do it. You just need to match it. So, and one more thing is, if this is of length 3, this has to be of length 4, that's for sure. Otherwise, now what you do is, you say BCDA, let's keep a pointer. BCD, let's keep a pointer. BB matches, let's move. CC matches, let's move. DD matches, let's move. Over here we are at A. A does not match, so let's move. So if at the end of the day, again, you have simultaneously, you have reached the end for both the strings, it is indeed sure, it is indeed possible. So if it is possible, that's how you can do it. You just need to match it. So, and one more thing is, if this is of length 3, this has to be of length 4, that's for sure. Otherwise, it's definitely not possible. So first check for length, then you can check for character matching, because the characters has to be same, right? So you just need to write this compare function. And if you are able to write this compare function, it's pretty obvious that you should be able to solve this. So what I will do is, I will now go back to the code. So here's the code. So let's go back to the longest increasing subsequence and pick up the code from there. So this is the longest increasing subsequence, which will pick up the code from. So I've just picked up the code. And now we don't need to print the subset, so we can definitely omit the hash stuff. We can just omit the hash stuff, and we can keep the maxi stuff. So let's omit the hash and let's keep the maxi stuff. So that's how easy it is. Okay, so we have declared the DP, then we have this portion of LIS, correct? Now if you remember, this is what I need to change. This is what I need to change. If I'm able to change this, I should be able to figure out the answer. Okay, so how do I change this? I just need to make sure, is it checked? Is it possible? Check for possibility of array of I and array of j. Just check for possibility, and that should be fine. So I just need to write the possibility code. So let's check for possibilities. Boolean check possible. Boolean check possible. You take string s, make sure you take by reference. String again s2, make sure you take by reference. Now the first thing that you will check is if s1 dot, remember this, s1 is the greater guy, s2 has to be the smaller guy, because you're moving in the subsequence part. So this has to be equal to s2. Like if this is by sure, like if this is falling at the first stage, then you say, hey listen, it's definitely not possible. If this is not possible, it's false. It's not possible. Or else you go for it. Let's keep a couple of pointers. Okay, so now you can keep the first pointer at 0. You can also keep the second pointer at 0. Amazing. Just keep on moving because you know for sure, you know one thing for sure. First is pointing to S1. First is pointing to S1. Okay. So if I try to write it in, like if I keep this as B, C, D, A, and the other one has B, C, D. So make sure the first point's here and make sure the second point's here. And now keep on comparing till both of them exhaust. Because you know one thing for sure, S1 is the greater one because you have checked for this. So S1 is definitely greater because if this is true, then S1 has to be greater than length. Cool. So we will keep on doing this till this is smaller, like it does not exceeds the bigger string. It does not exceeds the bigger string. So we will definitely keep on doing this. So I can say S1 dot first if is equal to S2 dot second. If that's the case, can you just move both of them? That's the first case. Or else if it is not, if it's not, then this guy at the first, this guy, like assume there was B, C, D, A. Okay, and assume there was something like BDA. So you need to insert C. So whenever this is like at the first case, B will match with B, so you will end up at here. Now C does not match us. So you move this guy only. You don't move this guy. This still stays as D. So what you'll do is you'll say, let's move the first guy only because that's where the insertion will be done. Once you have done this, at the end of the day, if first also reaches S1 dot size, that's the end, and the second also reaches this, then you can say please return that it's possible or else it's not possible. That's how you can compare. So in this way, you can have a comparison code, right? Pretty simple. So on running this, you'll see that you're getting wrong answers on 3 cases. Why does that happen? Because we solved this question thinking of subsequence. But if I give you an example like this, our thought process was, okay, this can be the first guy, this can be the second guy, and this can be the third guy. So we were saying that the longest length will be 3, right? But over here they see that, hey, listen, I don't care about subsequence. I can pick up from anywhere. Because if you read, it says sequence, not subsequence. You can pick up from anywhere. For an example, I'll say this will be my first guy. Okay, XB. Then I'll say this will be my second guy, XBC. This will be CXBC. This will be PCXBC. And this will be perfect. And I get a length of 5. And that's the answer for this particular test case. So if I do this, we are getting our answer. So it is a subset instead of subsequence. And if it's a subset, we have done this in the previous problem. What do? You can just sort them because somewhere down the line, if XB is the first guy, if the array had XB right here, XB, then XBC, then XBCF. So if you would have sorted it, then it would have automatically taken care of the length. It would have automatically taken care of the length, correct? So can I say I will sort it according to the length? Again, very important. I will sort it according to the length. So let's have a sort, but according to the length. So I will say sort array.begin, array.end, and I'll give a comparator so that it sorts it according to the length. If you don't know how to write comparator, you can watch out my STL video. I've taught you over there how to write comparators. So please go and watch that out. So I will say return s1.size because I am more concerned about sorting them according to the length. So this is how, if it's a smaller length, it's fine, it will return a true. Otherwise, it will return a false. So I've sorted them according to the length of the strings.